Hello viewers, good day to you all. So we have a question to solve which is still on this stoichiometry of reaction. The question reads determine the mass of carbon dioxide, which is CO2, produced on burning 104 grams of ethyne, which is C2H2, given the atomic masses of each element. Carbon as 12, hydrogen given as 1, and oxygen as 16. And we also provided with the equation of the reaction, which is 2C2H2 plus 5O2 as the reactant, and the product, which is 4CO2 plus 2H2O. So what we have to determine in this question is the mass of carbon dioxide. That's the mass of the product that's produced from this reaction. So for us to begin, the first step is for us to check if the reaction, that's the equation given, is the balanced one. So let's check. So the elements we have in this reaction are carbon, hydrogen, and oxygen, both on the reactant and also on the product side. So here's carbon has, we have 4 carbons here and also 4 hydrogens. We have 10 oxygens. Going to the reactant side, we have 4 carbons, 4 hydrogens, and also we have oxygen, which is 8 plus 2, that's 10. So looking at this on the reactants and the product side, elements are balanced. So this means that we have a balanced chemical equation. So we can move on and we can solve further from this. So from here we can see that the mole ratio is 2 ratio 5 ratio 4 ratio 2. So our comparison now is going to be between this reactant, which is the ethyne C2H2, and the product, which is 4CO2. Looking at this, we can see that 2 moles of the ethyne, which is C2H2, produces 4 moles of CO2, right? To bring out the molar mass of this, and the molar mass, calculating this is will give us the value for 26 grams per mole, while the mass of CO2, when we calculate, that is the molar mass here, is going to give us 44 gram per mole. Okay, so this what we just calculated here is the molar mass. The calculation of molar mass has been done in the previous classes. So the next thing we need to do now is to calculate the amount of ethyne reacted. So for us to calculate the amount of ethyne, that is C2H2 reacted, that's going to be, that is in small letter n, this is equals to the mass, which is small letter m, all over the molar mass, which is capital letter M. All of these symbols have been discussed in the previous class. You can watch my previous videos for better understanding. So here we have N is equals to, we have the mass given from the question, which is 104 grams of ethyne. So this is going to be 104 grams all over the molar mass, which we have calculated, which is 26 gram per mole. So here we have 26 gram per mole. From here, gram cancel gram, we are left with 104 divided by 26, which gives us a value of 4 moles. So the amount of C2H2 reacted is 4 moles. Moving on, the next thing we calculate here is, I'm looking at the equation, we can see that 2 moles of ethyne, which is C2H2, produced 4 moles of CO2. This is what we have stated here before. So from here, since 2 moles of ethyne produce 4 moles of carbon dioxide, therefore we say, so therefore 4 moles, which is what we have gotten now. Now 4 moles of C2H2 will produce, when we cross multiply, we are going to have, that is 4 over 2 times 4. Here, 2 here, 1, 2 here gives us 2. 4 times 2 is 8. So here we have 8 moles. Meaning that since 2 moles of ethyne produce 4 moles of carbon dioxide, it means that 4 moles of C2H2 produces 8 moles of carbon dioxide as well. You can see here we have 8. This is going to be 8 times the molar mass of CO2, which is 44. So we have 8 times 44, which is equal to 352 grams of CO2. Because in conclusion, we can say that 352 grams of carbon dioxide is produced by burning 104 grams of ethyne. So we write it in form of a statement: 352 grams of ethyne, which is C2H2, is produced by burning, as we have in the question, which is 104 grams of ethyne, 104 grams of ethyne. Please, for questions like this, you need to write out your answer, your final answer in form of a statement if you're answering an essay question, okay? So, viewers, in the next class, we shall solve more examples. Thank you for watching. I remain your tutor, Aisha Bende. See you in the next class, and bye for now.